Hey class, Mr. Moyden here with a video example of a kind of problem you are having to do for one of your homework assignments and eventually on assessments. The question is, find the value of x in this right triangle and then calculate the perimeter of the triangle. So let's go ahead and see what we have here. We have a given angle, in addition to the right angle. We have a length here, the missing value x here, and ultimately we need all three for the perimeter of the triangle. So let's go ahead and find x first, since that's part of our problem. X will be only, to find x rather, we need to figure out where it is in relation to our acute angle. So if we consider this as our angle of reference, then I'm going to go ahead and label all three sides actually in terms of their location. So from this angle of reference, the opposite would be directly across, so that's going to be my opposite side. My hypotenuse is directly across from 90, and that's irrespective or invariant to what the angle of reference is. And my adjacent side, relative to the 59 degrees, is this x right here. So opposite hypotenuse and adjacent labeled as such. So now the question becomes, which of my three primary trig ratios, which are sine, cosine, and tangent, but we can remember as SOHCAHTOA, which of these three is the best suited for this particular problem? Let's take a look. I have, let's see, from here I have the hypotenuse length, it's 12, and I ultimately want to find the adjacent length, which is x. So hypotenuse and adjacent is what I need for this problem. Well, hypotenuse and adjacent would be a cosine problem. So what that tells me is that I need to find the cosine of 59 degrees, and by definition cosine is going to equal adjacent, which is in this case unknown, over hypotenuse, which in this case is 12. Well, cosine of 59 is a value that a calculator or trig table can help you find. So I'm going to use my trusty calculator here. I'm going to be sure that it's in degree mode. So you hit mode on the TI calculator and then degree. So what is cosine of 59 degrees? You'll see that it's approximately 0.515. I'm actually going to keep that value in my calculator to make my calculations a bit more precise. Cosine of 59 is approximately 0.515, but it's really this number right here. Of course, that also goes on further, but that's okay for now. And that's going to equal x over 12. Well, I need to find the missing value. This is a fraction. It may help to interpret this as a fraction, which over 1 it now is. So from this perspective, this kind of gives you the idea of similarity. This is the original triangle, this is the specific one, and to have the same ratio, we simply cross-multiply to indicate that they're proportional in this way. So x times 1 will give me x, and 0.515 times 12. Well, I already have 0.515 in the memory of my calculator here, so I'm just going to multiply that exact number times 12, which gives me 6.18 approximately. So I'm going to round that to 6.2. I believe the homework says round it nearest 10th, so I'll try to abide by that here. So that means this length is 6.2. So I have most of what I need to find the perimeter. I'm still missing this length over here, and there's actually a variety of ways I could go. Now that I have two legs of the right triangle, the original hypotenuse and now I have the adjacent, I could use simply Pythagorean theorem to find the third leg of the right triangle. So one approach one could use is to recognize that now that I have both sides, it would be 6.2 squared, right, one leg squared, plus the opposite leg squared, I'll just call that y squared. So this thing here is going to equal 12 squared. So I could go through this approach. I'll do it real quick just so you have some more familiarity with it. 6.2 squared is approximately, or is 38.44. Plus y squared equals 12 squared is a gross 144. Subtract this quantity to maintain balance. I'm going to do it to both sides. Leaving me with y squared is equal to 105.56. Square root both sides to isolate my variable. Y is equal to approximately 10.3. So I'm using one decimal place there just for clarity's sake. So that's 10.3. Now I have enough material with which to create the perimeter. Oops, didn't realize I was off screen there. Let me scroll up a bit, 10.3. I now have enough to make the perimeter. However, we've been learning trig, and it's always useful to have a couple of examples. So I want to show you an alternate approach. So once we get this value, we could branch off and do the Pythagorean theorem. We could, however, continue down the trig route. Maybe you've gotten the trig bug and you like to continue on with some trigonometry. So by that I mean, if we didn't have the 10.3, right, if all we had was the 12, and then we found the 6.2, which is useful, but really all I need is the 12 and my angle of reference. This time I want the opposite, and I have still the 12 given hypotenuse. So in that case, opposite hypotenuse would point me toward sine. So once I have my first value, since I'm ultimately needing all three, I can go ahead and use trigonometry and say sine of 59 degrees is going to equal opposite over hypotenuse. I don't know what the opposite is. Hypotenuse is still 12. Sine of 59. Earlier I did cosine of 59 because I wanted the adjacent, but to get the perimeter I need the opposite as well. Sine of 59 is approximately 0.857. And that equals y over 12. And I'll express this as a fraction to make it clear the relationship between these parts proportionally. Y times 1 is y is equal to this number here times 12. Giving me, what do you know, 10.3. So either way, you get the same value. So it's kind of, student choice, whatever one you feel more comfortable with or like to use. Either method will get you the same length. Let's finish it off by finding the perimeter. The three side lengths in this problem are approximately 6.2 plus, running out of ink here, 10.3 plus 12, which should give me, let's see, too late in the day to do it in my head. Wouldn't be too hard. 28.5. So there's our perimeter, and there's the value of x. Alrighty, hope this helps.